Hello and welcome to my 8th combinational circuit video. This one is going to be on propagation delay. And so just a quick demonstration of what kind of propagation delay is and how it affects a circuit is we can look at this like very basic circuit here. And what propagation delay is that it's saying that because signals take time to reach the next step in the circuit, there will be very brief periods of time where the outputs are inaccurate. And so just sort of give a demonstration of that. So here we have a simulated version of it's an AND gate with one input, one part of that input going through a NOT gate, and one part of that going through nothing. So theoretically, this would always return 0 no matter what, because there's never a case in which both inputs are the same. However, via propagation delay, there are fractions of time where this output is actually 1, and we can kind of go through what that would look like. So if we change this to 0, and we almost frame by frame watch this circuit go through. So if I press this button, okay, so this is initially what it's going to look like. It's going to be 0 is going to go through here, 0 is going to go there. It hasn't reached the NOT gate yet, so this is still 0, and so they're both 0, but it also hasn't. The one also, like, this is supposed to output 1 in this case, but it hasn't reached it yet because the electrons are still moving. So in that case, we keep going, and well, this is actually kind of back to normal. I guess there wasn't a period in which it returned 1, but I guess that's fine. But if we look at it from the other way, we make this a 1, and then we do the propagation. So now they're both returning 1, and what it shows in Logisim is that, oh, it actually does return 1 for a fraction of a second. Remember, this is sort of a frame-by-frame sort of view, even though this is inaccurate. But when we go one step further, okay, boom, now it's back to normal. Now it returns 0. And so that's kind of an example of there being a delay in a circuit, and it tangibly affecting our output, making it incorrect. And so this can be sort of made true for other circuits as well. Here we have, we can go on this one right here. This is an adder 4, so this adds 2 4-bit inputs. And it also has the capability of taking in a carry in. So we can say, let's add, I don't know, let's add 8 to what is that? 6. 8 to 6. So that should give us 14. And if we go through the propagation here, we can just watch it work. So initially, it says, okay, all of these are 0, this is 1, this is 0, this is 1, this is 0, this is 0, this is 1. But from the last input, it's still returning a sum here, and it still has a carryout, even though this has no carryout, and this has no sum, because it's 0 plus 0 plus 0. But because in the previous edition, we did have a carryout and a sum, that's what it's going to look like. But we take it one step further, okay, now it goes to the step where, okay, like the computation is being done. Keep going. It's still, like, this is 3 frames further, and it's still outputting an incorrect sequence. Still incorrect. Okay, boom. Now our sum is good. Boom. Now our carryout is good. Looks like our sum is okay too. Keep going. Oh, there we go. Oh, that's right. So it isn't actually that was incorrect. So we just keep going, and we can carry that all the way through until we get to the very end. And see, this is taking way, way, way longer than the last one. And boom, we finally have a correct answer, I think. Oh, yeah, okay. Yeah, it's so we have a correct answer. And that's pretty much it. So the reason that this one like took so much longer than the last one was because there's so many more gates and wires involved in this circuit. And there are cases in which Logisim actually returns an output of E, which means error. Didn't happen to be in that sequence, but in the previous one there actually was an output of E, and so there can be special quote unquote fluctuations where it doesn't even have like an identified output, which is quite interesting. And then lastly, we should discuss Logisim's propagation, like what are the limitations to Logisim, and it's kind of outlined in this shortcomings sort of section here in the user guide. They seem to be quite specific, but all in all, I think it's very well outlined by this initial heading here. It says, Logisim's propagation algorithm is more than sophisticated enough for almost all educational purposes, but it's not sophisticated enough for industrial circuit design. And then it says, in order for most to least damning, here are the shortcomings, and then it gives all these like kind of hyper-specific instances where Logisim might fall short, especially in terms of like that industrial circuit design environment. It doesn't concern itself with timing issues. If pins act as inputs and outputs, Logisim can't simulate those kinds of subcircuits. Like just things that are a lot higher level that wouldn't really be relevant to this class. So those are kind of like the major shortcomings, or I don't know, relevant shortcomings, and that's kind of where you could find them, is in that user guide. So yeah, that is it. Thank you for watching, and I'll see you in the next video.